Welcome to section 3.1, where we get into quite a few more of the identities in trigonometry. And so we begin with finding the exact value. And basically we get into what are the inverse functions, or as this right here is said, this is the arc sine of root 2 over 2. And basically all we're asking is, where does the sine of an angle, or what angle has a sine that is equal to root 2 over 2? And this does equal pi over 4. Now there are several, there's a few stipulations that you need to be concerned with, and you need to get those from the book, realizing that the arc sine will have a value between negative pi over 2 and pi over 2, as will tangent and both of their reciprocals. Cosine and secant will have a range somewhere between 0 and pi. And so you just need to consider that when you actually find these answers. Number 2 asks, what is the arc cosine of negative root 3 over 2? Well, now this being negative and we're dealing with cosine, cosine's either going to be in arc cosine is quadrant 1 or quadrant 2. The place where it's negative is in quadrant 2. So we know our angle has to be quadrant 2. And then we look at root 3 over 2. Well, the only place that cosine is equal to root 3 over 2, we look at the reference angle here, and the reference angle is pi over 6. But what we are really interested in is, what is that angle right there? And that angle is 5 pi over 6. And so that would be the answer to number 2. The final problem in this particular section is the arctangent of negative root 3. Once again, where is tangent negative? And tangent, arctangent can either be quadrant 1 or quadrant 4. The only place that tangent is negative in those two quadrants is down here. And then what we need to determine is, where is it equal to root 3? Well, the place that tangent equals the square root of 3 is pi over 3, and that would be the reference angle. However, we need to appropriately name this, and so this would be the negative angle, or negative pi over 3. Example 4 and 5 asks us to use a calculator and to round it to 2 decimal places. Once again, there's no way I can show this, so this is just a matter of getting the correct answers. And so the first thing we want to make sure is that we are in radian mode, so make sure you do that. But then after that, it's just a matter of plugging in the values, and the arc sine of 0.7 is 0.78. And number 5, the arc cosine of 4/7 is 0.96. Now, number 6 and 7 are word problems that we need to deal with. And we are given a pretty obnoxious formula where D represents the number of daylight hours, or the approximate number of daylight, and we're given all the information within it. However, we are told that it needs to be expressed in radians, and so the problem does deal with a degree. 46 degrees 52 minutes is equal to 46 Sorry about that. Had to go in to get my calculator because I just can't do division all that easily, especially at this level. And so what we have here, 46 degrees 52 minutes would equal 46 0.87 degrees. Now that still doesn't help us because we need to convert this into radians. And so converting this into radians, what we're going to do is we've got the 46.87. We're going to divide by 180 and multiply by pi so that we get 0.8179, so on and so forth. Realize we do want to keep that value in our calculator as we do the calculation, and then at the very end we can do our rounding. So D is equal to 24 times 1 minus the arc cosine of the tangent of I. Well, according to this problem, I is 0 degrees, which is also 0 radians, and tangent of theta, and theta is the 0.818 as we calculated earlier, all divided by pi. And so when we do all of this calculation, it does actually end up being an extremely simple number, and that is 12. D represents how many hours, so we do want to make sure and label it so that we get the 12 hours. Number 7 deals with what happens when we submerge or change a medium that we are viewing something at. And we have angles of refraction, angles of incidence, and so on and so forth. And we are given a formula within the problem number 7. And so we are asked to find theta sub r given the appropriate formula, which is arc sine of n sub I is 1.46 over n sub r, which is 1.36, times the sine of theta sub I, which is 8.5 degrees. Now, as long as our calculator is in degree mode, this is very easily calculated, and when we plug all this in, we end up with 9.13 degrees. Now, if you truly want to, you can go ahead and do the calculations to convert each one of those to radians, but I would strongly suggest just going with what they give and then going from there. 8, 9, and 10 asks us to find the exact value of the expressions and not using the calculator. Now, quite often, whenever we have inverses of each other, for example, the arc sine of sine, oftentimes it is the exact same answer, but we do need to look. The sine of 6 pi over 7. Well, that is positive, and the arc sine of that would show up either in quadrant 1 or quadrant 2. In particular, where it's going to show up is in quadrant 1, because, or the sine of 6 pi over 7, 6 pi over 7 is over here. And so that's going to equal something, but the point remains that pi over 7 is the reference angle here. When we take the arc sine of it, arc sine can only be in quadrant 1 or quadrant 4. So where it's positive is right here. And so it's going to have the same reference angle, pi over 7, which happens to be the actual name of the angle in standard form. And so this equals pi over 7. Number 9, we have the arc cosine of the cosine of negative pi over 6. Now, once again, first thing we're going to do is go to negative pi over 6, which is down here, and the reference angle is pi over 6. So we could calculate the cosine of this, but we're asking where does the cosine, and well, first thing we want to do is the secant of this. All students take calculus is positive. So when we take the arc cosine can only be in quadrant 1 or quadrant 2. So we have to put it into quadrant 1 because that's where it's positive. And the reference angle remains the same. And so this would equal pi over 6. Example number 10 is the arc sine of the sine of 7 pi over 6. So once again, we need to draw the 7 pi over 6, which puts us down here. Reference angle is pi over 6. But when and the sine of this, the secant of this sine would be negative. And so arc sine either has to be in quadrant 1 or quadrant 4. Well, the only place where sine is negative is here in quadrant 4. So we're actually looking at this angle right here, and the reference angle is pi over 6. But we have to name this appropriately. This is not pi over 6. Pi over 6 is up here in quadrant 1. So this is actually called negative pi over 6, because we do have to go to the negative in this particular case, because arc sine has to be somewhere between negative pi over 2 and positive pi over 2. Number 11 and 12, we need to find exact values. We are not allowed to use calculator, but sometimes this might be undefined. So we have the sine of the arc sine of negative 0.3. Okay, where does sine equal negative 0.3? That, and it has to be in quadrant 1 or quadrant 4, so apparently that has to be here in quadrant 4. And so we have some angle, we'll just call it alpha, that the sine is equal to negative 0.3. And so then we ask, what is the sine of this? Well, the sine of this would be negative, and it happens to be the exact same value that's there. I mean, there's nothing else that we could actually use to determine this. As the final example for this particular video, we're going to look at example number 12, and that is the sine of the arc sine of 1.3. Now, where is sine positive? It's somewhere here in quadrant number 1. So we have some angle that is equal to 1.3. Then we ask, what is the sine of that angle? The sine of that angle is going to be exactly the same, except for the fact the range of sine is between negative 1 and positive 1. And this is well outside of that range, and so this is not defined.